Okay, welcome back. So let's start our discussion from where we left in the previous module. We looked at the Indian specific scenario and some comparison with the global scenario in terms of e-waste management. Now we'll start in terms of that why question. So why e-waste management is important, what are the concerns? So we'll start looking at what are the elements of concern, what are the chemicals of concern in terms of electronic waste management. So if you look at, there are several elements from the periodic table. And again, these I'm not going to cover in like line by line from each of these elements. I will provide you this slide so that you can read it, and especially on the danger part. So we'll just cover the first two columns in more detail, and then just very quickly we'll talk about this third column in this from this table. We have actually, the list is pretty long. So it started with and the list has been provided in alphabetical way. So it doesn't mean that arsenic is the number one element that shows up in electronic waste. Actually lead is. So we see most electronic waste, the higher amount is lead. But in terms of since we listed it, we put them in alphabetical order. So electronics that we carry, phone, iPad or anything, laptop and other stuff, carries many of these heavy metals or metalloids. Arsenic is used in semiconductors. We use them in semiconductor, diodes, microwaves, LEDs and solar cell. The solar cell also uses arsenic. And we all know, like I'm talking to you sitting in West Bengal. And West Bengal and Bangladesh, we do have several areas of arsenic pollution issues. There is even in Bihar we have arsenic pollution, Madhya Pradesh, Rajasthan. So there are pockets of many places in the country where we have arsenic issues. But most of those arsenics are geogenic. We are not talking about arsenic from electronic waste as went there. But arsenic is a potential carcinogen. It's a chronic exposure to arsenic can lead to various disease, and also it can cause lung cancer and can often be fatal. So for this part, this column, I would let you read it. It's all a general description. I will highlight few points over there. Then barium. Barium, it's used in electron tubes, filler for plastics, rubbers, lubricants, additives. Beryllium, which is used in switchboards and printed circuit boards. We have brominated flame retardants. Brominated flame retardants, say when you are using your laptop, especially if you are carrying the laptop and on your laptop is called because you can put that the small computer on your lap and work from there. So this when you are working like that, you see that after maybe half an hour, 40 minutes, depending on the model and make of the laptop, you start feeling the lot of warm. It's very warm there because it started getting hot. So when it starts getting hot, if there is a trigger of any kind of short circuit or anything happening, it may catch fire. To prevent that, we use this brominated flame retardants. So preventing of flame retardant, as you can see, when is it retarding the flame? So you are not letting the flame to propagate. So that's why it's a brominated flame retardant. It's a halogenated compound. Bromine is a halogenated compound and used in casing, circuit boards, cables, PVC cables. So and then here it leads to if you it's at lower temperature releases toxic emissions, dioxins, which can lead to severe hormonal problem. So here for beryllium, we know the chronic beryllium disease, a disease which primarily affects the lungs. It also causes a skin disease. And for barium, it can lead to brain swelling, muscle weakness, damage to heart, liver, spleen. So they have seen the blood pressure changes, changes in the heart from ingesting barium. So all these have certain concern. That's why we are worried about electronic waste management, proper management of e-waste, because we have all these pollutants there. And not only on this, we have we have these pollutants there, and then that leads to several danger that the health impact is there from these pollutants. So just again continuing the list, if you can go to the next. So we have cadmium, chrome, which is chromium, cobalt, copper, lead. Again, these are in alphabetical order. Cadmium, nickel cadmium batteries. You always hear about cadmium, nickel cadmium batteries, which is batteries. It is used in batteries, used in pigments. Solder, the soldering which is done on the printed wire board, circuit boards, computer batteries, Cathode ray tubes, cadmium is used a lot. Cadmium is a carcinogen. As you can, carcinogen means something which can cause cancer. Long exposure also cause Ita disease. Ita disease means our body actually gets confused between cadmium and calcium. All of us has looked at periodic table at some point in our life. So if you remember from the periodic table that cadmium and calcium, they are together very close to each other in the periodic table. So our body gets confused between cadmium and calcium, and it thinks that it is calcium. We all need calcium. That's why when you were young, your mother was kept on telling you to eat milk, drink milk, because milk has calcium there. We need calcium for the growth of our bone, growth of the teeth, and later on in our life, when we get older, many times we use calcium supplement as well to keep our bones in a good condition. So, but if the body get confused between calcium and cadmium gets into our body, so wherever we need calcium, the cadmium goes there, but the cadmium doesn't do the function of calcium. So it becomes our bone becomes brittle, and it starts creating problem. So in that case, what happens is it leads to a lot of problem in terms of like a bone damage and other stuff. So that's why cadmium it's a very much of a concern in terms of electronic waste. Cadmium coming from the e-waste. Then chromium is used in dyes, pigments, switches, and also in solar panels. Cobalt is used as insulators. So cobalt is used as an insulator. Copper, copper wires is there, copper ribbons, circuits, pigments. Lead, which is number one concern in terms of electronic waste is because of lead. Lead is a neurotoxin. It affects kidney, reproductive system. It also damages the brain development. So it's that's why if you go to a petrol pump today, when you fill up your car or a bike, you see on the label there it says unleaded gasoline. Why it says unleaded gasoline? That means at some point of time we had lead in that gasoline, isn't it? That's why it says unleaded. Why we got rid of lead from the gasoline? All the smoke pipes, the exhaust pipes of this car or the bike, it's at a lower level. And when our kids are walking on the road, they are also at that level too. And then when this is smoke coming out, and if it gets ingested, it goes into the lungs goes into the body of these small kids, it affects their brain development. So it's a neurotoxin. That's lead creates problem. That's even the whole there is a theory that Roman Empire that collapsed because of the consumption of alcohol in a leaded vessel. So with the leaded vessel, alcohol, low pH, lead got released into the alcohol, and people drank those alcohol, and they their brain got damaged. They started acting crazy. They start fighting among each other, and the Roman Empire collapsed. So that's one theory. May be true, may not be true, but lead does lead to lead exposure does lead to impact on brain development. It's a well-established fact with lots of research done on different subjects, and there are some even data like epidemiological data which supports that. So lead is a big issue. That's why this whole issue of electronic waste is started. Then you have others. It's there. You can read about these for the other impacts. So essentially, what all these pollutant does, it has some sort of negative impact on our body. So that's why we are worried about them. Then we have lithium, liquid crystals are there, lithium is there, mercury, another big pollutant, mercury, which is present, nickel is present. So components, mercury is there in copper machines, steam irons, they are also there in batteries, they are there in the batteries, in clocks, pocket calculators, switches, LCDs, they affect the central nervous system, kidneys and the immune system. Nickel, lung cancer, nose cancer. So, and lithium is corrosive to the eye. So, all these have certain negative impact, and lithium is a lot of in mobile telephone. We see lithium there, photographic equipment, video equipment, batteries, lithium is there. So, that's lithium batteries. So, we always hear about that. So, all of these had certain negative environmental impact and our human health impact. That's why we are worried about that. Then PCBs, plastics, selenium. So PCBs is your polychlorinated biphenyl. PCB was very popular, again used as a to prevent any sorts of fire and other stuff in transformers, capacitors. It is a softening agent for paints, glue and plastic. It says has serious non-cancer health effects, including effects on immune system, reproductive system, nervous system, endocrine systems. So, these are all documented. PCBs are plastics, circuit boards, cabinets, selenium uses in photocopies, fax machines. So, and then they have their negative health impact right there. So, you can so these are and the list, actually there are some more which we will look at. Then we have silver, zinc, toner dust, americium, chlorofluorocarbon. So, they are used in capacitors, switches, brass, alloys, toner cartridge, medical equipments, fire detectors. Chlorofluorocarbon uses a cooling unit, insulation foam, and they have certain health impact from these, which is listed over here. Okay. So, it is listed over here, as you can see. So, there is a from silver, zinc, toner dust, americium, chlorofluorocarbon, similar to what you saw from the other. So, what we are trying to get out of these long list of pollutants, they are all there on the periodic table. They are used in electronics, in different proportion, in different quantities for the function that we want out of the electronics. These are needed over there. So, first, they also have some value. Most of the electronics items are a bit, you can say, things are getting cheaper, but they are comparatively pricey items. If you go to buy a good cell phone, it's still 10 to 15,000 rupees. So, it's at least, and then of course there is no limit. You can go and buy for several lakhs as well. But these heavy metals are present on those electronics. Now, when you discard them or when you put them in a environment back, these will leach off from these during the recycling operation, especially by the informal sector. They will leach off, they will go into the soil, they will go into the water, and then we will have, if we use that water, if to drink, you are getting exposure to these heavy metals, and you saw all the dangers associated with these different heavy metals. If it goes into the soil, we grow our food on those soil. That food may have uptake because of many plants have the plants also get confused between calcium and cadmium like our body does. And so, plant may think that especially there has been documented evidence where they saw that many paddy, which is staple food, the rice, were found with cadmium. We could see cadmium showing up in rice and the rice plants. The paddy thinks that cadmium, they cannot distinguish between cadmium and calcium. So, again it will think we want, if its calcium is there, it's good, isn't it? So, but if cadmium shows up, it's bad. So, that is the reason we have to be careful. If it goes to the soil, it will have impact through the food. If the children has a hand to mouth activity, that is another impact. We will talk about this in that risk assessment video. And so, these are, so essentially lots of heavy metals and other pollutants which is there in electronic waste. We need them because for the function to get out of those electronics. If managed improperly, they have a very high probability of contaminating the water, contaminating the soil, and part of it could go into the air phase as well. So, we need to manage the electronic waste properly to avoid the danger which has been listed in the third column, which I strongly encourage you. I did not go by line on those. I strongly encourage you to read that. You will have this as this slide will be available to you as a reading material along with other reading material. Go through that. Any question, ask me on the discussion forum. We will be happy to answer. But so that is why that is the reason we are talking about. And the other side, if you look at, these are heavy metals which are being mined from Mother Nature, being brought into the our like a value chain in the economy. So, there is a money associated with that. If we can recover these heavy metals and bring it back into the economy rather than dumping it into the soil, dumping into the water, dumping in the environment or in a landfill. So, if we can bring it back into the economy by doing this recycling and recovery of these heavy metals, we do not have to go and mine, and we can use these heavy metals. We do not have to go and mine. And some of the other precious metals has not been listed here, like a gold is also present in a very minute quantity. We will talk about that as well later in this course. So, So, these are the reason why why we are looking at electronic waste in terms of like a different elements present, different pollutant present. So, disposal type, what are the major disposal type? Incineration, things are being burned, many times it is a uncontrolled burning of electronic waste. As I told you that we'll during the discussion forum, we'll put some YouTube link videos for you to look at, and where you will see that e-waste is just burned in an uncontrolled fashion, and that leads to, if you burn at say uncontrolled fashion, it you can have like brominated flame retardants will can lead to extremely toxic dioxins and furans. PVCs will generate toxic flue gas. If you put it in landfill, you have lead, cadmium, chromium, mercury, all these things going in there. PCBs, PBDs, they can go there. Landfills, in the way the Indian condition right now, mostly it is the dump site. So, if it goes to those dump sites, what it will lead to is leaching of these heavy metals into the subsurface, and that will leach can potentially go to the groundwater, and we can get exposed through that. So, it's again exposure through the contaminated groundwater could be a problem. Recycling, we need to be careful in terms of the hazardous emissions due to the recycling of plastics, halogenated, heavy metals, lead, cadmium and other stuff. We need to make it, we need to make sure the process is safe and proper. So, shredding without proper disassembly, that can cause hazardous substance dispersed into the environment. So, we need to be careful in terms of hazard associated with improper disposal. And then it comes to the why we should focus on recycling. We don't want to put this electronic waste in landfill that much or in incineration. We should try to recycle. As I said just earlier, a few minutes back, many of these heavy metals and other elements present there, they have a value. They have been mined from Mother Nature and gone through all those refinery process, and then it's being used in e-waste. So, rather than putting it back into the landfills or burn it and then make it unusable form, can we recycle and make it in a usable form? So, landfilling of e-waste can lead to leaching of lead and other things into the groundwater. Lead is just used as an example here. So, that goes into the groundwater. If the CRT is crushed and burned, it may emit toxic fumes. Cadmium from one mobile battery is enough to pollute 600 meter cube of water. So, one from your mobile phone, the cadmium that is present there, if you just put it in a river, where the cadmium becomes available to the river, it can pollute 600 meter cube of water. Think about that. And then, so there is a huge impact of health and environment because of e-waste around, in terms of improper management of e-waste, and right now barely 4% of e-waste produced in India is recycled. So, nearly 95% is just getting dumped because of the poor technology, and then things not getting into a proper hands. So, that is why the e-waste management rules, which we will talk about that, 2016 came into being. First one was in 2011, which was supposed to be implemented from 2012. Unfortunately, nothing much happened. Then again in 2016, the rule has been refined a little bit, and then we are trying to implement it in the country. We are struggling to implement it even now, but things are being tried to implement it. And there are a lot of new companies are showing up in terms of the e-waste management. Companies are, hopefully the market will pick up, and the registered companies will get the job. So, there is a huge gap between the generation and recycling of e-waste, and any recycling is good as long as it helps the environment. So, if recycling, why do we need to recycle? To help keep the city clean, provide value for obsolete electronic items. So, we can use that many times. If you have say 3 broken down computers, if you can just salvage the material from there and then you make one working computer, that's actually refurbishment, not recycle, but that should also be encouraged. And then it can be sold at a cheaper price on OLX or eBay, on wherever you want to do that. And if you recycle, if you keep it within the loop, you are avoiding health hazards. Things will not go into water, will not go into the soil. We have to organize the informal sector. That's true for municipal solid waste as well. We have a good informal sector, especially in the Indian context or maybe some other developing countries context. The informal sector does a very good job in terms of the collection of the garbage, collection of the recyclable material from the waste stream, including that for electronic waste. So, electronic waste if these kabadiwalas or the e-waste recyclers, those who have their nice network, they can come and collect the e-waste from you. And then the problem comes in when they are trying to recycle. When they starting recycling, up to dismantling it is fine. It's not too much of a technical intensive exercise. Dismantling, you need only some screwdrivers and some of the other tools to take it apart. So any electronic waste, when say think about, let's take the example of a CPU, like the computer, the central processing unit of a computer. If you discarding that, you can unscrew it. The top casing is mostly steel, like a ferrous metal, or it could be plastics nowadays, but mostly it's a steel, which you see in the disposal stream. So that can go to a steel recycler, and anything which is plastic can go to a plastic recycler. The problem comes when we start looking at that motherboard, printed wire board, and all those material where we have lots of heavy metals and other things present there. So we have to start recovering stuff from these, and there where we start when we start recovering these, we start using some of these aqua resia, which is a very concentrated form of nitric acid and sulfuric acid. We start using some of these other extraction methods without any environmental control, without even personal protective equipment. And that leads to all those exposure to the person working there, air pollution, water pollution, and land pollution. So if that aspect, so if somehow we can do a nice like a marriage of the informal sector and the formal sector, where this informal sector does the collection part and brings it to the formal sector, and the formal sector can take care of let the low hanging fruit be with like we have a recycling of ferrous metals already happening in the country. We have recycles of certain types of plastics already happening in the country. So let's that be handled along with plastics, along with the steel recycling. The major stuff which has those heavy metals present, the printed wire boards and other things, motherboard, other different types of boards, capacitors and batteries and all those which is present, that requires a specialized recycling system. And that when this informal sector tries to do it, they end up contaminating a lot to the environment. To avoid that, if we can get the formal sector helping the informal sector in that aspect. So again, we have to look at how the economics will work. Right now, this informal sector, they come to our houses and we even give them, they even give us some money. Say if they take some old cell phone from you, they may give you 200, 300, 400 rupees, depending on how good that cell phone he or she is thinking about will fetch him money, because they will, but if you go for a formal sector which has set up a company which has to follow, ideally they should, SPCB norms, CPCB norms, Ministry of Environment and Forest, they have invested a lot of crores of rupees, few crores of rupees on that plant. They may not be in a situation to give you some money on the day one. They have to start making some money themselves. So there will be a break even time when they will break even, and then they will start making profit. So to expect getting little bit of money from them to give you a product is kind of a little bit too much. So if you are especially if you look at the developed countries, like if you are in Canada and other places, you actually pay for e-waste disposal rather than getting money from e-waste disposal. So that's where the problem comes. People like us we always want money from everything, and then the formal sector cannot give us the money because they don't have money to because they have to follow all the rules and regulations, so they have to spend a lot of money there. But informal sector, they don't have to follow any rules and regulations, so they are okay to give you few like a little bit of money, and then they get this e-waste from you and try to recover whatever they can recover, and whatever they cannot, they just dump it. They just dump it in the environment, and that creates a lot of problem, and people like you and me get affected. So then we pay the medical bill. So first we get little bit of money from electronic waste, and later on we as a society I'm talking about, and then as a society we ended up paying little bit of like a lot of money to all these hospitals. So we have to think what we need. Should we what will be best for the society, how to go about managing that part. So that's the of the organization of the informal. So getting this informal sector into the formal sector, and that will lead to reduction in the environmental degradation. So that will in terms of the recycling. So recycling of e-waste is the most preferred option in terms of managing of e-waste. So that's in terms of So, next in this series, so far we have talked about what is the e-waste, what are the pollutants there, the Indian scenario, global scenario, how the e-waste is changing, why we should be worried about it, why recycling is important, what is the state of e-waste recycling in India right now. Then next, so we will start thinking about if you have to quantify e-waste. So, think about that if we have to design a e-waste management system for a particular city. The first question that will come to your mind is how much is out there, how much e-waste is there, how to find out that number. There have been some studies done in the old times, but if you are just focused, say if you are focused in Delhi city or Kolkata city or Mumbai city, it would be nice to know how much e-waste is produced in the city itself. So, for that there is a method that we will talk about, that is the quantification of e-waste. And as you can see in here, in terms of the quantification of e-waste, just I will introduce this topic and then we will cover this in detail in the next video. So, in terms of quantification, there are different methods out there. There are various evaluation methods are available. They are put in different groups. There are the disposal related analysis, there is a time series analysis. Disposal related analysis, what they do is they look at the e-waste figures obtained from collection methods, treatment facilities, disposal sites, or they get the data from the disposal stream. So, they get or they requires empirical data from parallel to estimate overall generation. So, they look at how much is being disposed, and based on that they do some estimation. Time series analysis is essentially used for projection. We forecast the trend of e-waste generation by extrapolating the past data. So, we take the historical data of the past and then we try to extrapolate in future. And then it is used to fill in the gaps of past unknown data sets as well. So, that is in terms of disposal related analysis, time series analysis. So, there are different methods out there. You can go on literature and try to find, there are a lot of things are there, and then there is a factor models, input output analysis, and so, these are the four major analysis methods that is used. Factor model use determined factors for correlation. Input output is this is used mostly for multiple model variation. You try to generate e-waste generation for the regional scale or the country study, we try to do that. So, just wanted to introduce you to these four concepts so that you can try to get some more information about these different methods. I will encourage you to read. See, again, this is a specialized course. This course is a specialized course focused, I would say it's mostly for high, which is 4th year undergraduate students taking it as elective, or master's PhD student, or some people working in the professional. So, I do expect you to do some of the reading on your own as well. So, certain topics will be introduced here, but we do not have time to get in great detail on those topics, and you can, those of you who are interested can research today with the help of Google. You can actually find a lot of information, good information. So, all these different four methods of estimation, and this is not only for e-waste, it is done for other scenarios as well. So, I would encourage you to look at those four methods, so that when in the next video, when you look at the next video, you are a bit more familiar. So, we will about these four methods, and then we will discuss it in more detail. So, with that, let us close this. We will continue our estimation of e-waste in the next, and then we will have a case study for the city of Kolkata of how we can do a e-waste estimation there. So, again, keep your questions active on discussion forum. We will definitely answer that, and we look forward to having your discussion. Give your feedback along as the course is going on. If you want certain things to be more discussed, put it there. We will try to do it, and any way we can help you to learn better, that's always will be our pleasure. Thank you.